So today we are going to bring you with the bridge course. So many people have a question, what exactly bridge course is meant for and why we are giving you bridge course. And bridge course is specifically meant for your preparation to make a very good base for you to fulfill your dreams, to get into a very good aims or a very top medical college or the best medical college of your state. And I am today going to introduce you the bestest of the team across India who is going to teach you for this bridge course. So let's not delay. I'll start introducing each and everyone. Now I'm going to call the amazing botany teacher who have done his masters and PhD from IIT Bombay and have mentored so many top 10, top 50, top 100, top 1000 rankers across India and हजारों बच्चों को आज तक डॉक्टर बनाए हैं. And we are going to call Dr. Kunal sir. Sir, please. So Kunal sir is here and sir लगभग अभी 10-15 साल से पढ़ा रहे हैं and by IIT Bombay he have completed his PhD from IIT Bombay and he mastered the way a student has to master botany and पिछली काफी साल से हर साल काफी number of students से too many number of students for scoring 180 out of 180 perfect scores in botany. I'm very sure sir आपका जो experience है बच्चों के लिए काफी help होगा. And now let's call zoology ma'am, Anisha Sarkar ma'am, and ma'am worked in top-notch coaching institutes and she's also working since almost 12 to 13 years. And imagine every year, if you see last year, highest number of perfect 180s she have produced, and it's been almost 12 to 13 years she have been producing top 10, top 100, top 1000 rankers, and many are in the bucket of her her list whom she have produced as doctors. And now let us call our chemistry guru Anirudh Mehta sir, and an amazing teacher, a fantastic teacher, and he has been a top-notch mentor for most of the kids to reach their destiny, to get into aims and two good medical colleges across India. Sir ने भी rank 1 दिए हैं और top 10 rankers को mentor किए हैं, and he also mentored so many rankers across India, and he has been a part of our system since a long time. I'm very sure sir ka bhi his experience will definitely help you to master and make a very good base for your bridge course. Now I would like to call VS Star sir. VS Star sir काफी पॉपुलर और फेमस है. VS Star sir सर का तो शायद अभी आप जिन सबसे you are learning your subjects, he is the most senior most and one of the top notch faculty and well known in India and have produced rank 1 multiple times in India. He have mentored so many students to produce single digit rankers every year and very popular as VS Star. I am very sure this star will definitely elevate the star of learning your physics, and आप सबके अंदर का जो star है उसको he will definitely initiate them. And this is the team which is going to be with you for the coming 26 days, and they will make a proper foundation, a proper bridge between your transition from class 10 to 11 to fulfill your dreams. Thank you everyone. Without any delay, let's go to Anirudh sir because it's your chemistry class first. All the best and please keep focus. All the best.
Thank you very much, Gandhi sir. So a very warm good afternoon to all the lovely students who are watching me. Is my voice audible and I am visible? Just ping a yes if it's so. And we are going to start our session after this. Yes. Am I audible and visible to everyone? All right, guys. Hello. So first of all, very warm welcome, and I would like to congratulate you for choosing science stream after your 10th standard. I hope you would have done great in your 10th as well. So my name is Anirudh and I'll be your chemistry mentor for the next upcoming days, almost a month. What are we going to do in this next 15 to 20 days is what I'm going to tell right now. All right, everyone, you can just keep the comment session away from you for some time, listen to me, take out your notebooks, take out your pens, and then we are going to start. So, my name is Anirudh and I've been teaching here in Shri Chaitanya for a long time, as sir has told you. Without further ado, let us start with our session. So as you know, coming from 10th standard, you had a simple book of science. Now it has divided into 4 different books, which is going to be your chemistry, physics, botany and zoology. It sometimes feels little overwhelming to see such large books, but trust me, if you follow on with your teachers, they are all great teachers. They have all been very good in their subject. So once you follow them, you will see that it will just be a cakewalk for you. Okay, so let us start with our chemistry lecture. Fundamentals of chemistry is what I am going to teach you today. Just basics will not keep anything very tough today. Slowly as you become more comfortable with me, I am going to teach you little tougher parts as well. Okay, so deals with matter. Matter, its classification and its interconversion from one state to another. Interconversion of matter from one state to another. All of you, please focus here and see many of the things you are going to see today which you have seen before, and many new things also you are going to discover. Okay. So what is matter then? What is matter then? You would have heard the definition of matter many times. We say matter is anything which occupies space and had some mass. Okay, matter is anything which occupies space and has mass. Okay, you might think, sir, then everything is matter. Everything is around you, that is around you, is occupying some space. Like this pen is occupying some space. If I put it on the weighing scale, it will have some mass, 10 gram. We are matter, my specs is matter, your benches are matter. Is there anything which is non-matter also, which is not a matter? Let's think. So whenever you do a mistake, and then you say sorry to the other person, he said doesn't matter. What is the meaning of doesn't matter? You are saying everything is a matter, but when you are saying sorry to someone, he says doesn't matter. So he wants to say that you don't have to be sorry, because whatever mistake you have done, that mistake is not occupying any space in his brain or in his heart. Okay, that's the meaning of doesn't matter is. So what is that which does not matter? Things that do not matter are these things. So anything which has mass, occupy space, are called as matter. For example, molecules. We are going to see what are the meaning of molecule, atom, compound. I know these terms are sometimes confusing for many of you. What is an atom? What is a molecule? What is a compound? I am going to teach you everything. For example, CO2, carbon dioxide, gas. Although it is very light particle, but still it always has some mass, as all of you know. Air is a matter. Air contains so many molecules. Cat, gases. I hope all of you are understanding what a matter is. All of you have seen matter in daily lives. What is a non-matter? A non-matter is something which you can't weigh, which you cannot weigh. Like, for example, can you weigh light? Can you weigh heat energy? Answer is no. Okay, the light that is traveling to us, it does not carry any mass. Okay, in later studies, you will, in later part of the chapter, you will study that light has a particle-like nature. It does not mean that light carry any particle. Okay, a particle-like nature is very different from having a particle. A particle or a matter is the one which has mass. Light does not carry any mass. Okay, so light, heat, thoughts, our thoughts do not have any mass. Okay, you keep thinking, you keep overthinking, you burden yourself, but that burden is only mental burden, but not actual weight burden. Okay, gravity, which is also a form of energy only. Okay, a force does not have any mass. So I hope it is clear to you what is matter and what is not matter, right? Now we'll talk about how do we classify matter. How do we classify matter? So matter basically has two general classification. It is classified into two types. One is called as pure substance. pure substance, the very first classification of matter is in the term of pure substance and impure substance. The impure substance is also known as, what is it? Mixtures. Mixtures. Okay. Slowly we'll learn what is a pure substance, what is a mixture. You have to keep writing when I am writing. Okay, with a nice handwriting, you start making your notes. Take a new notebook for this next 25 days. You will be enjoying this a lot. Okay, today I've kept little less questions for you, but slowly as we move forward, I'll give you more and more MCQs also. Okay, so a pure substance versus a mixture. What is a pure substance? A pure substance is the one which is made up of identical type of particles. Identical type of particles. Okay, what are these particles? We are just going to see. And they have a fixed composition. Throughout. They have a fixed composition throughout. Right. Whereas, what is a mixture? So let's first talk about pure substances. So pure substance is further divided into elements and compounds. Elements and compounds. If you are getting doubts in your mind, sir, what is atom, what is molecule, what is compound, please wait for some time. All the doubts will be cleared. See carefully what I am telling. Okay, so pure substance can be elemental pure substance or a compound pure substance. Okay, what is an elemental pure substance? A pure substance which is made up of only one kind of atoms. Only one kind of atoms. Made up of one kind of atoms. One kind of atoms. Okay, definition of atom will also come, but right now, as all of you know, that there are 118 type of atoms which are already discovered, which you put it into the periodic table. So element is made up of one kind of atom. Now, for example, an element can be metal or a non-metal or a metalloid. Okay, so a pure substance of the elemental type can be of three further subtypes, everyone: metal, non-metal and metalloid. Can you tell me some examples of metal? I hope all of you, as soon as I say metal, the first thing that comes to your mind is silver, gold, AU, gold, right? Sodium and so many, aluminium, copper, zinc, these are all metals. Non-metal. Now everybody, non-metal like oxygen, I will not mention it as O, I will mention it as O2. I will mention it as O2. I will mention ozone as O3. So everyone, please see carefully. Element does not have to be in atomic state. Element itself can be a molecular state. Okay, an element is a pure substance. It must contain only one kind of atom, like O atom, but O atom does not exist in nature. No. Have you ever seen O? Have you ever seen something like N? That does not exist. What exists in nature, the form of oxygen, is O2, O3. So element is different, atom is different, completely different. I will tell you the definition of atom in some time. So Ag atom, it exists as a single atom. So Ag is atomic form of element. Oxygen does not exist. O does not exist. So O2, O3, N2, nitrogen. Sulfur exists as S8. S8. Phosphor exists as P4. Then you will say, sir, do non-metal never exist in the form of in the atomic form? They exist. For example, argon. A noble gas exists in monoatomic form. Okay, helium exist in monoatomic form. I hope it is clear to everyone. So element has nothing to do with a monoatomic or a diatomic or a triatomic. Element has to contain only one kind of atom. There may be single atom present like helium and argon. There may be two atoms attached together like O2, N2, H2. I hope it is clear to everyone. And metalloids are those kind of elements which have a property in between that of metal and non-metal. Some of their properties are like metal, some of their properties are like non-metal. For example, one of the best example of metalloid is silicon, germanium, and many more. Once you study the periodic properties, we are going to see many more metalloids. Okay, so elements is clear to us. Anything which will contain only one kind of atom. Alright, what is a compound now? A compound is a pure substance which is made up of what? Made up of what? More than one kind of atoms. 2 atoms, 3 atoms, 4 atoms, right? So made up of 2 or more kind of atoms. Made up of 2 or more kind of atoms combined in fixed ratio by mass. This is also very important. Fixed ratio by mass. If you do not say fixed ratio by mass, in that case your definition could go wrong. Okay, so a compound must contain some elements, different atoms. Those atoms are combined in a fixed ratio by mass. Can you say a few examples of compounds? So I have kept the chat off for some time. You understand why we have done that, but you keep saying it, keep writing it in your notebook and you match it with me whether you are saying correct or not. Okay, so a compound, maybe if you are saying the example, some of you might be saying, sir, glucose is a compound, C6H12O6. You might say, sir, carbon dioxide is a compound, CO2. It contains 2 different types of atoms. Water is a compound, H2O, HCl, hydrogen chloride, and such as copper sulfate, CuSO4. So the compounds can be classified into 2 types. We can call them as ionic compounds and covalent compounds. You can have a different classification as well, like organic compounds, inorganic compounds, right? When we study different types of chemistry, then we can also call some as inorganic compounds and organic compounds. Compounds of carbon containing hydrogen, they are organic compounds, and the ones which do not have carbon and hydrogen attached together are inorganic as well. But right now we'll keep more of the definition in other way, which is ionic compounds and covalent compounds. Ionic compounds are nothing but these are your salts like sodium chloride, the table salt that you eat. NaCl is a compound, it is in solid state, correct? So as a chemist or as a student also of chemistry, never ever forget to mention the physical state in the bracket. Okay, it's a very bad habit to not mention. My bad habit also, you just saw, they are all solid. So in bracket S you must write. These are all gases. In this sulfur and phosphorus they are solid. So you can mention S8 bracket solid, P4 bracket solid. Others are gaseous here. So bracket gas I am mentioning. Silicon, germanium, they are all solid in nature. Okay, as a brain teaser question, do you know any metal which is liquid at room temperature? Yes, it is mercury. Mercury is liquid at room temperature, right? And do you know any element? Do you know any metal? Yes, very good, Teja. Do you know any metal which is solid at room temperature, but as soon as you take it in hand, it melts into liquid? Do you know anything which melts in your hand? Liquid in palm, but solid outside. Mercury to liquid only, no? Yes, gallium. Very good. There is one more, cesium. Okay, there is one more, cesium. So cesium and gallium both melt in hand. You can remember it. Cs, cesium, Ga, gallium. They both melt in our hand. They both melt in our hand. All right. So NaCl is an ionic compound. Copper sulfate dot 5H2O. Okay, we call it as blue vitriol. That is an ionic compound. It's a very bright color, blue color salt. Okay. Covalent compounds are those which have covalent bonds. In the bonding chapter we are going to study, like carbon dioxide. So how do you know a compound is ionic or not? If any name you are doing it as EM8, EM-ide, EM-ite, these are all ionic compounds. Okay, as a trick, if you want to remember, there are still more of the complications inside it, which we study under something called as Fajan's rule, which says that nothing is purely ionic, nothing is purely covalent. But for now, anything you call it as EM8, EM-ide, they are all ionic. Sodium chloride, magnesium sulfate, calcium phosphate. Okay, and anything which does not end with an EM and an 8, they are going to be covalent, like carbon dioxide. There is no EM in this, no? Carbon dioxide, water, glucose. Always mention the physical state in the bracket. CO2, gas, HNO3, yes, nitric acid. HNO3 is also a covalent compound. HCl is also a covalent compound. Okay, as a good question can be asked, most of you do a mistake of considering HCl in an ionic compound. HCl is not ionic compound, beta. It's a covalent compound. That's why HCl is a gas. An ionic compound is never gas. It is always solid. A salt is always solid. It can never be gas. It can never be liquid. Has to be solid. Okay. So HCl, HBr and so many. This is about covalent compounds. Right. Very good. So we have understood what is a pure substance. Okay. Now comes what is a mixture. A mixture. Okay. A mixture, as the name suggests you, it is made up of two or more pure substances mixed together in any general ratio. It doesn't have to be a fixed ratio. Made up of two or more pure substances mixed in any ratio by mass. Any two things you take which are pure and mix them together. Best example, air. What is air made up of? N2O2. Beta, there is nothing called as carbon chloride. There is something called as carbon tetrachloride that is also covalent, CCl4. Good question. CCl4. Yes. So, when we mix any two or more pure substances together, what do you get? You get a mixture. Have you heard of alloys? The gold chain that I am wearing, in this what is there? Gold is there, some copper is also there. Okay, so it's a mixture. So everything around you mostly is a mixture only. You say nothing is pure in today's world. You say paneer is also not pure, milk is also not pure. All things are only mixture. Very few pure substances are there. So when I mix CO2 plus N2 together, I get a mixture. When you drink cold drink is a mixture of gas dissolved in water plus some sugar also. Okay, all these things are nothing but mixtures. Now a mixture can be of two types, mere bachche. Two types of mixtures are possible. What are they? Homogeneous and heterogeneous. What is a homogeneous mixture? What is a heterogeneous mixture? Okay. Homo means same composition throughout, and the size of the particles is so small, that we cannot differentiate between the two pure substances by our naked eye or by microscope. I'm not writing the definition here. I'll just speak it out. You can write quickly, or just 2 points you can mention. Mixture where the constituent particles constituent particles are not differentiated either by naked eye or by microscope. Okay, that is called as a homogeneous mixture. Homogeneous mixture in other terms is also called as a true solution. True solution. Okay, they are invisible type, means you cannot even tell that the two things are mixed together. For example, if I say air is a mixture of N2 plus O2 plus CO2. When we say air, no, we generally neglect the dust particles. Okay, when I say smog, smoke, then you are considering the dust particle along. But if I say air is a homogeneous mixture. A mixture of any two gases is always a homogeneous mixture. Mixture of any two gases, N2 plus helium. Okay, I hope my voice is clear to everyone. Any two gases mixed together make a homogeneous mixture. Sugar in water, very good, Sagar. So I can call it as sugar aqueous. Whenever we say a true solution, bracket we say AQ, aqueous. Chapter name not very important right now. Okay, yes, not milk, beta, not milk. I'll just come to it. Milk is not a true solution. Okay, milk is not a true solution. By naked eyes you can't see the two particles in the milk, but under the microscope when you see, you will see oil particles separate in the milk and water particles separate. So milk is a mixture, not a heterogeneous mixture of oil plus water. Okay, you can easily see them, differentiate them by microscope. Sugar solution, salt solution, NaCl aqueous. Very important example, alloys like brass, like bronze, like 22 karat gold, 20 karat gold, 18 karat gold. These are all steel alloys. So alloys are this, yes, brine solution, NaCl aqueous is brine solution as well. Now comes heterogeneous solution. Let us further classify heterogeneous into. So heterogeneous are further of two type, beta. One is called as colloids. One is called as suspension. Colloids, suspension. Okay. Colloids have particles little bigger than true solution. So by naked eyes you still cannot see the different particles, but by microscope you can still see them. Okay. So for homogeneous true solution, microscope does not work, naked eye do not work. For colloids, you can differentiate colloids, can be differentiated or distinguished. The two constituent can be distinguished via microscope. They can be distinguished via microscope, not by naked eye. For example, milk and blood, very, very important example, milk and blood. Both are heterogeneous, but when you look at milk from very near, using a microscope, you'll be able to see the oil layer as separate layer, milk layer as the water layer as separate layer. You might have observed sometimes. Okay, just tell me if you have. When you are making tea, okay, once you have made the tea, after some time the cream comes on the top, no, what we call malai, that comes on the top. When you remove that malai, you see some bubble type oil particles on the milk. You might have seen. You have seen the bubble oily particles on the top of tea or on the top of milk when you heat it. Yes. So yes, you can sometimes see them with your naked eyes as well when they are having little larger size. Same way blood is also a type of a heterogeneous mixture, colloid. Okay, all right. You can say paint also here if you want. Okay, there are many more. We'll just keep it till here. Now suspension. Suspension is something you can see it by your naked eyes only, that they are different things. For example, if I mix sand in water, sand will just settle down. Sand will just settle down. So they can be distinguished by naked eye also. So their particles are very large. Our eyes also can see them, like sand in water. Okay. When you mix two solids together, okay, when you mix two solids together, you have taken some sand, some salt, you have just mixed them, salt plus sand. You can take smoke, dust particles in the air. You can easily see where is the smoke and where is the clear air. That is also a heterogeneous mixture. I hope classification of matter is very clear to you. Only two things are unclear to you. Sir, what is an atom and what is a molecule? I still have not told you what is an atom, what is a molecule. Just write a thumbs up in case it is all clear to you up to now. Okay. Now I am going to tell you what is an atom and what is a molecule. Okay. Oil and water, sir. Oil and water is a suspension. Oil and water, if you can see the two layers separately, it's a suspension. Okay. So you do this experiment at home. I'll give you one experiment. You take some oil, probably you take soybean oil, which is your refined. Take some water. Okay. You will see two layers separate. You will see two layers separate. That is a suspension. Then you take your blender, hand blender is there at your home. Take that hand blender and blend it together. It will become mayonnaise. It will become mayonnaise. That mayonnaise is going to be a colloid. All of you have eaten mayonnaise. Yes, mayonnaise is nothing but olive oil plus water plus some egg also. Yes. Okay, bacha. Right. Sir, groundwater. Water in general, we'll say water is a, if they say pure water, you call it a pure substance. Groundwater is homogeneous only. Groundwater means just some minerals are there. Okay, the water that you drink, it's mineral water only, no? So homogeneous solution, you can say water plus some salt plus some KCl, Ki. Okay. Next, let us go to what is an atom and what is a molecule. Okay. Concept of atom, molecule, element, compound, all are different. I've already told you what is element. I've already told you what is a compound. Now coming to what is an atom or what is a molecule. Remember this definition, everybody. Atom is the smallest particle of an element which may or may not have independent existence. Atom is also the smallest particle which takes part in a chemical reaction. Atom is the smallest particle. No. Smallest particle of element is not atom. Okay, what you are saying? Smallest particle of element is not atom. It is electron. Further, you can break atom into electron, proton, neutron. So there are subatomic particles. Atom is not the smallest thing ever. Atom is the smallest thing which takes part in reaction, which takes part in chemical reaction. So atom is smallest entity of an element. Do not stop your pen here. If I stop my pen here, I reach to 18th century in the time of Dalton. That was the problem of Dalton. No, he said atom is indestructible. It is the smallest particle. It is not. It has been destructed into electrons, protons, neutrons, right? So smallest entity of an element which takes part in chemical reaction. Okay, so when you take N2 plus H2 combining to give ammonia, N2 is not taking part in reaction, mere bache. Nitrogen atom is taking part. Hydrogen atom is taking part. Atom may exist independently, like helium, like argon, may not exist. Like hydrogen does not have an independent existence. There is no such thing as H in this universe. There is only H2. There is no such thing as N in this universe. There is N2. So nitrogen, hydrogen, oxygen, these atoms don't have an independent existence. Whereas helium has, sodium has, right? So this is the atom, right? These are some of the atoms that I am showing here. Hydrogen does not exist in nature. Lithium exists. Carbon, fluorine, neon, and so many. What is a molecule? What is a molecule? Very important. We say atom may have or may not have independent existence. Molecule is bound to have 100%. It is true that molecules always exist independently. What is molecule? Molecule is the smallest substance, pure substance, smallest pure substance which is sure to have independent existence. CO2 is a molecule, O2 is a molecule, O2, O3, they exist independently. O does not exist, O is an atom, but O exists in the terms of O2 as a molecule. Okay, so it is the smallest particle of an element or a compound, means that's why I said smallest particle of a pure substance, I said, which can exist freely 100%. This is a H2, 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 hydrogen, O2, 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 oxygen. Phosphorus, I told you, P4, solid. Sulfur as S8, water as H2O, H2O, H2O. Okay, so molecule and compounds are different things. This is a compound, also a molecule. This is an element, also a molecule. This is an element, also a molecule. This is an element, also a molecule. This is an element and a molecule. This is a compound and a molecule. CO2 is a compound and a molecule. I hope it is clear to everyone. I know many people had doubts in this. Are your doubts cleared now? Many people till today, they'll start studying chemistry, they'll do equilibrium, they'll do all difficult chapters. But when we ask them, just tell me the difference between a molecule and a compound, they struggle. So can you tell me, is it clear to you? Yes. Is helium a molecule, sir? No, helium is an atom. As a bad habit, we use it as neon, we use it as noble gas molecule. No, helium is an atom. It's not a molecule. Okay, it's an atom. Yes. So this is about our atoms and molecules. Now let me give you some more examples of atoms. So these are already I've told you. So these are metallic elements. So gold is made up of AU atoms joined together by metallic bonding. Okay, this is carbon, which is a non-metal. It contains carbon-carbon atoms like that. Element, I just told you what is the meaning of element. I told you the elements are classified into metals, non-metals, metalloids. Okay, all of this we have already discussed. Compound, I have already told you what is a compound. Pure substance which contain more than one type of elements and have different properties than constituent elements. Okay, a compound has a completely different properties from a constituent element. A compound is made up of atoms combined in fixed ratio by mass. Now, for example, if I say a simple reaction like hydrogen combining with oxygen to give water. Okay, I'll just write it a proper chemical equations with the proper states. H2O gas, O2 gas gives H2O liquid. Never ever leave any reaction unbalanced. Okay, it is one of the biggest mistake that we are doing. So I'll just say H2 plus half O2 give H2O. Those who do not know balancing yet, wait for 2-3 classes, I'll teach that as well. H2 plus half O2 H2O, or you can also call it as 2H2 plus 1O2 2H2O. I hope all of you know this balancing. Properties of water are nowhere near to the hydrogen and oxygen. Hydrogen is a highly flammable gas. Okay, hydrogen is a highly flammable gas. Okay, whereas water is not at all flammable. Water though is used to, stop the flame. So hydrogen is responsible for fire, water is responsible to block the fire. So they are completely different. Yes. As you move on to the next chapter, you will see that we'll go more towards the quantum as well. That is correct what you are saying. Okay. Right? So So all these things I've just told you. These are some ionic compounds. These are some covalent compounds. Today's class is just an introductory class, bache. From next class, we'll be starting with many MCQs and everything, assertion, reason type of question. Today, I'm just giving you a kind of a bridge between 10th and 11th. From tomorrow, we'll start going towards more of the 11th standard. We'll study mole concept. Have you all done mole concept as well before? Have you all done mole concept before in your 10th and 9th? Yes. Okay. We'll do MCQs. So, next we'll talk about, so whenever you want to study about atoms, let us talk about the theories of atom. You can stop the comments. Let us talk about theories of atom. The very first theory of atom was given by Dalton, which we also called as Dalton's atomic theory. Okay, Dalton's atomic theory. Although today we have completely failed it. Okay, we are now at a very advanced theory of atom. We call it as quantum mechanical model of atom. Okay, quantum mechanical model of atom. But before, much time before, we have Dalton's atomic theory. After Dalton's atomic theory, many more theories came as electrons were discovered. J.J. Thomson gave his own atomic theory. Then Rutherford gave his own atomic theory. Then Niels Bohr came and gave his atomic theory. So many people have given the atomic theory. They are trying to improve themselves time over time. Okay. So many people say, sir, since all these theories are wrong only, why are you teaching us? Right? Why are you teaching us? So you only tell me. If I directly start, if you are a kid and you are learning, alphabets, if the very first word that I give you is Czechoslovakia, write Czechoslovakia. Will you be able to write? You will say, sir, it's so boring. How do I do this? It's so difficult. So just to make your path little easy, just to make you understand from the basics, we are going to learn these theories. But keep it in mind, they all will have their own drawbacks. They all will have some good points. Some points of Dalton's theory are still valid today. Like Dalton said that in a compound, elements combine in fixed ratio by mass, which is law of definite proportion. It is still valid. In CO2, carbon and oxygen are combined in fixed ratio by mass. So many things are correct also from Dalton's theory. Many things are incorrect also. You want to see? Let us see. Okay. You can mention these points after the class in your notes. All matter is made up of tiny indivisible particle. This is where he did a mistake. Okay. This is what Dalton's thought. Dalton thought that atom is indivisible, but today we have divided atom into electrons, protons and other subatomic particles. All atoms of a specific element are identical in mass. That is correct. Absolutely correct. But then there is a problem. I'll ask you. Okay, I'll ask you. All atoms of a specific element are identical in mass, size and other properties. Can you tell me why this is wrong? Okay, just one word answer I want from you. Just one word answer. I want a one word answer from you. I'll open the chat for some time. I want a one word answer from you that why this is wrong. Just one word answer. Atoms of an element are identical. Atoms of an element are identical. Why this is wrong? One word answer I need. Yes, that is very good. Srikar Bodhati, Srikar, if I am pronouncing your name little wrong, please excuse me. Okay, Srikar is correct. Isotopes is the answer. Isotopes. Yes, isotopes will have different mass numbers. H is also hydrogen. D, deuterium, that is also hydrogen. Tritium is also hydrogen. Yes, very good. So he was wrong in this concept also. He thought identical mass, but it's not true. However, atoms of different elements exhibit different properties. This is also wrong now. If I say two different elements must have different mass, not true. Isobars. Calcium can also have mass 40. There is potassium also possible with mass 40. Right? So yes, isobars, isotopes, these are the problems which Dalton did not know about, but it is a very old theory, so we can give him that much credit that he was a very intelligent person. That's why we say Sir Dalton. We never say John Dalton. We say Sir Dalton, okay, with utmost respect for his theories. Atom can neither be created nor destroyed. Again, this is wrong from the Dalton's point of view, okay. Furthermore, atoms cannot be divided into smallest particle, but they can be divided into smaller particles like electrons, protons, and other subatomic. So these are all wrong things, but Dalton had said like this. Okay. So these are the limitations. We'll keep the class till here right now. Just learn the limitations today. Tomorrow when I come, I'll start with the questions. Whatever you have studied today, I'll ask questions from there in the tomorrow's class. We'll start with 5 questions and then we'll go towards the next topic, which is one of the beautiful topic of physical chemistry, which is mole concept. Tomorrow I'll teach the mole concept. These are the limitations. It does not account for subatomic particles like electron, proton, neutron. Does not account for isotopes as you just told me. Does not account for isobars as you just told me. Elements need not combine in simple whole number ratio to make compounds. This is also very important points. Beta, there are some compounds which are called as non-stoichiometric compounds, where elements are not combined in a simple whole number ratio. More about this tomorrow I'll teach. Something like Fe 0.930. Such a compound also exists. You might not have seen it yet. Okay, so these type of compounds also exist where the number is not a whole number. Theory does not account for allotropes as well. So it says that carbon must have same structure. An element must have identical structure, but carbon can have different structures. Carbon can be in form of graphite, in form of diamond, and so on. Okay, I hope it is all clear to everybody. It was so nice meeting you. It was so lovely to teach you all about the matter. And I will see you all in the next class with another beautiful topic, mole concept. Bye bye. See you again. My name is Anirudh, signing off. See you.